In this video, we're going to do a moments question. So have a look at the question. It tells you the plank is 30 kilograms and 6 meters long. There's a nice diagram of the setup here. Part A, define the principle of moments. Part B, how far along the plank can the boy walk before it tips? And the boy is 38 kilograms. I would suggest you pause the video now and have a go at this question. So the principle of moments for an object in equilibrium, the sum of the anti-clockwise moments about a point equals the sum of the clockwise moments. So there's only really one way to say this. All that's saying is if we think about all the moments that are trying to rotate it this way, they will equal all the moments that are trying to rotate it this way if it's an equilibrium. That's an important bit, if it's an equilibrium. For part B, how far along the plank can the boy walk before it tips? So at some point, the boy will get to a point over here where his moment will be greater than the moment turning the plank the other way. And we're trying to work out what this distance is here, which I'm going to call x. So what is trying to stop the plank from tipping? Well, it's of course the weight of the plank. So if it doesn't say otherwise, then we can assume it's a uniform plank, and a uniform plank means that the weight will be exactly half the way along the plank, so at exactly 3.0 meters, which means that the distance to the pivot is going to be 1.2 meters. This, of course, is the pivot if the boy is over this side and trying to make the thing tip. Obviously, if the boy is over this side, we've got this support force from the bank, so that won't apply. So we're going to take moments about this point here. So we're going to say that the weight of the plank is going to be 30 kilograms times by 9.8 newtons per kilogram. That's gravity, or the strength of gravity, and that's going to equal our moment from the boy. So the boy's mass is 38 kilograms times by 9.8 newtons per kilogram, and then times by this distance x. So if we rearrange that and solve it, we get 30 times 9.8 divided by 38 times by 9.8. We get a distance. Oh, no, I've made a very silly mistake here. Can you spot the mistake I've made? I haven't done moments at all, have I? We should be doing moment is force times distance, or force times perpendicular distance. So what have I missed out here? We should be saying not any of that. 30 kilograms times by 9.8 newtons per kilogram times by the distance to the pivot, which is 1.2 meters, is going to be the boy's mass times by gravity times by this distance. So I missed out the distance of the weight from the pivot. So now we can solve this equation. And we get x is 0.9. We actually get 0.9 recurring. So effectively, x is 1.0 meters past the pivot, or depending on exactly how the question is worded, we might want to say that the boy can walk 4 meters along the plank, because they can obviously walk 3 meters and then they can walk 1 additional meter before they get to the point where it tips.